Let us start the miscellaneous NCERT exercise on relations and functions. Now before doing this exercise, let me tell you, you have to listen to everything that I say very carefully, and it is recommended that you write everything that we say here. Okay, so you make your notes and then you can write them in your language. Okay, I'll help you understand each and every question, but you have to write it yourself in your notebook. So let us start with the first example here. Let R be the set of all real numbers. Define a real function R to R by f of x equal to x plus 10. We need to sketch the graph of this function. So if you look at this function, f of x is equal to x plus 10. So in other words, I can write y is equal to x plus 10. X plus 10. So I'll put values of x. Accordingly, I'll get some values of y. And we have discussed that these values that I get, because this is defined in real numbers, so these values that I get will act as the coordinates in Cartesian coordinate system. What I mean is, now see, this is a linear equation. This is something that we know already, because x has got, the variable has got power 1. So this is the linear equation, and the graph of this will be a line. And for a line, for a unique line, I need at least 2 points. At least 2 points. So if I am given 2 points, 2 distinct points, I can draw a unique line. So I just need 2 coordinates to draw this line. So let me show you how to get the coordinates. If I write x here, y here, if I put, let us say, x equal to 0 in this given equation, what will be y? Y will be 10. If I put, let us say, y equal to 0, if I put y equal to 0, what will be x? X will be equal to minus 10. So I have got 2 points, I can draw a line. Or in other words, I can sketch the graph of the given function. So what are the coordinates? One of the coordinates is this, 0, 10. Right? Another coordinate is this, minus 10, 0. So 0, 10. This is 1, 2. Let us say this is 10. Okay. So this is 0, 10. Obviously this will be on y-axis because x coordinate is 0. And what is this? This is minus 10, 0. So let us say this is minus 10. The coordinates of this point will be minus 10, 0. Now what is my graph? A line passing through these points. Okay, so this was a simple question, and this format is nothing but this. A line can be written like this: y equal to mx plus c. Okay, this is an equation of line which we will study in straight line also, but I think some of you must know it already, that this is an equation of a line. First of all, this is a linear equation. Now this m is coefficient of x, this c is a constant term. M also has got a special name, which is slope of this line. Slope of this line, let us say. And for example, in this question, what was the slope? Coefficient of x was 1. So slope of this line was, or m in this was 1. And what was c? C is called y-intercept. Where is it cutting y-axis? At this point, right? Y equal to 10. Okay, x is 0, y is 10. So what is y-intercept here? It is 10. So as you can see in this equation, value of c is 10. So you can always write a general equation of line in slope-intercept form like this: y equal to mx plus c. Okay, we will study about this in straight line chapter also. But for now, you should know this much: y is equal to mx plus c is an equation of a straight line. Look at this one. R be a relation from Q to Q, right? Defined by R. Okay. Now Q, what is Q? Q is a set of rational numbers. Set of rational numbers. And what are the elements that are there, or the ordered pairs that are there? A comma B, such that A and B both belong to rational numbers, and A minus B belongs to integers. Okay. So let us check. For the first part, A comma A belongs to R for all a belonging to rational numbers. And how do we check that? Right, this is the given formula, a minus b belongs to z. This is what I need to check. If let us say this operation on first entry and second entry satisfies this relation, I'll say that this particular ordered pair is in this relation. So let us check a comma a. So if I put a minus a here, it will be equal to 0, which is an integer, right? So yes, it satisfies this. And a and b belong to rational numbers, so you can put any rational number in place of a. Let us say 1 by 2 minus 1 by 2, it is equal to 0. 5 minus 5 is equal to 0, or minus 5 minus minus 5, it is equal to 0, right? So it is giving me 0, right, which is an integer. So yes, it is there in this relation. Okay, so we had to show that a comma a belongs to this relation. So a comma a belongs to this relation because a minus a is equal to 0, which belongs to integers. This is something that you have to write. Look at the second part. A comma b belongs to this relation implies that b comma a will also belong to this relation, which means that it is given that a minus b is an integer, right? Because a comma b belongs to this relation. This is given. Okay, if a minus b is an integer, this will imply that b minus a will also be in this relation. That means it will also be an integer. So if a minus b is an integer, then I can say that negative of an integer is also an integer, So I can very well say that b minus a is also an integer, or in other words, b minus a belongs to integers. That means I have shown the second part by writing these statements. Okay, so this much is enough to show that the second part is true. What about this? A comma b belongs to R, b comma b c belongs to this relation, implies that a comma c also belongs to this relation. So what it means is a minus b is an integer. This is given, or in other words, you can write a minus b belongs to integers. B minus c is an integer. This is given, right? So b minus c belongs to integer, and we need to check whether it implies that a comma c or a minus c belongs to integers or not. Now look at a minus c. A minus c, can you write a minus c like this? A minus b plus b minus c. Can you write a minus b as a minus b plus b minus c, because b and this minus b will be cancelled and it is nothing but a minus c. So this is this, right? So a minus b is an integer, b minus c is an integer, so their sum will also belong to integers, right? Or you can say sum of two integers is also an integer, right? So the third part is also verified, or it is also shown in this way. Let us talk about this statement here. Now this is a linear function, so it will be of the form y equal to mx plus c. We just discussed it. From z to z, find f of x. So we are talking about integral values like from z to z, and we need to find f of x. So let us consider f of x equal to mx plus c, because it is a linear function. Okay, now I have considered this, and all these points will fall on this line because these belong to this set f, right? So these are coordinates through which this line is going. So I can very well put these coordinates in this equation. So f of 1, right, is 1. So f of 1 is m into 1 plus c, and it is equal to 1. Because of this coordinate, it shows me that when I put 1 in this linear function, it will give me 1 as my value of the function. So f of 1 is 1, which gives me this equation. I just need two equations to find the values of m and c. So the second equation I can get, let us say, use this coordinate. F of 2 is 3, right? As per this coordinate, f of 2, when I put x equal to 2, I get y equal to 3, or f of 2 as 3. So what is f of 2 as per this equation that we have taken? M into 2 plus c, and it is equal to 3 because of this coordinate. So this should give me my second equation, that 2m plus c is equal to 3. Now I just need to solve second and first, these two equations, to find values of m and c. So if I subtract first equation from the second, c will be cancelled, and 2m minus m will give me m, 3 minus 1 will give me 2. So value of m is 2. Now if I place value of m as 2 here, I know value of c will have to be minus 1. So I've got the values. So what is my linear function? It was mx plus c. So if I place value of m as 2, so it will be 2x, and value of c as minus 1. So this will give me my answer. Okay, I hope this question was very simple for you. Now I need to find domain of this function. So to find domain of a rational function f of x by g of x, I need to ensure that the denominator doesn't become 0 for any value of x. So I have to exclude those values of x for which this denominator g of x becomes 0. So if you look at the denominator only, it is x square minus 5x plus 4. Where is it 0? Let us see. If you factorize it, x square minus 4x minus x plus 4 equal to 0. So it will be x common, x minus 4 minus 1, x minus 4. So factorized form is x minus 1 into x minus 4 equal to 0. So this denominator will be 0 when x equal to 1 or x equal to 4, right? So I can write x square minus 5x plus 4 will be 0 for x equal to 1 or 4. See, and what is the domain of this function? Domain of this function, apart from 1 or 4, I can put any real value of x, right? I can put any real value of x. I just don't want this denominator to be 0. Apart from that, any x that is real is acceptable. So any real value apart from 1 or 4. I'll use these brackets, discrete brackets, so that only 1 and 4 are excluded, right? You have to differentiate between these brackets, right? If you write this, then you have excluded all the values between 1 and 4 also, right? You have not excluded 1 and 4, but you have excluded all the values between 1 and 4. This is not something that is appropriate here. This is wrong. So you have to use these discrete brackets. Okay, so only how many elements are there in this bracket? 2 elements, which are 1 and 4. So this is what is being excluded from the domain. Okay, look at this function. This has been defined before 0, at 0, and after 0. Before 0, it is defined by this rule 1 minus x. At 0, it is 1, and greater than 0, it will, so before 0, it is defined as 1 minus x. At 0, it will give 1, and after 0, it will return x plus 1. So if I put, let us say, x equal to 2, then I'll use this definition, and f of 2 will be equal to 3. If I put minus 2, I'll use this definition, that is before 0, right? So f of minus 2 will become 1 minus minus 2, that is 3, right? And what is f of 0? It is 1. This is the meaning of this function. I need to draw the graph of this function. So to draw the graph, we already know that I will find some points and then plot it on the graph, right? So let us say these are the coordinates. When I put 2, I get 3. When I put minus 2, I get 3. And when I put 0, I get 1. So when I put x equal to 0, I get value 1. So this is one of the coordinates that will be there, 0, 1. And when I put, let me find some other points also at 1 and minus 1 also. Okay, at 1, if you put x equal to 1, this definition will work. So 1 will give me this point 1 comma 2, and minus 1 also gives me the same value, that is 2. When I put x equal to minus 1, right, this definition will be used. So 1 minus minus 1 will be 2. When I put x equal to 1, this definition will be used, which will give me 1 plus 1 2. Okay, and if you look at this value also, you will realize something here. When you put 2, you get 3, and when you put minus 2, you get 3. So this will be a graph like we drew a modulus function. You remember? Modulus function also had a similar graph. Just the difference is that it is taken above by 1 point. If you remember the definition of modulus, or let me clear the confusion, this function is nothing but 1 minus x, mod of 1 minus x, right? And it is mod of 1 minus, no, it is x plus 1 here, so it is not mod of 1 minus x. It is a different function altogether. So we have solved it, because when I put x something negative, so this is the solution that was required in this question. Let's not extend this discussion any further. So this is my solution, okay? And on the right, the definition that is being used is this one, x plus 1, right? Here it is x equal to 0, and on this side the graph is y equal to 1 minus x. Okay, the relation f is defined by this, f of x is this and g of x is this. We need to show that f is a function and g is not a function. So let us focus on f first. F of x, if you see, is defined at two places. Basically it is being defined between 3 to 10, right? 3 to 10, and then there is this 0. So before 0 it is x square, or you can say, no, it is being defined between 0 to 10. And how can 3 be before 0? So it is being defined between 0 to 10, and then there is this 3. So between 0 and 3, between these two values, it is x squared, and at 0 and at 3 also it is x squared, and between 3 to 10 it is 3x. And if you notice, at 3 it is being defined by x square as well as 3x. You need to focus here, right? Between 0 and 3 it is x square, between 3 and 10 it is 3x, and at 3 is included here also and here also. So it has got two definitions at 3. If you notice, f of x equal to x square is very well a function. We have already studied about it, and x can take any real value. F of x equal to 3 of, let me write, f of x equal to x square is a function where x belongs to any real number, and f of x equal to 3x is also a function where x belongs to any real number. So what is the confusion here? Now, why do we check this for a function or not? Because at this point, that is x equal to 3, this function has got two definitions, and we just need to check whether it gives different values at x equal to 3. Because for some relation to be a function, it should give a unique value at certain value of x. It should not give two values for a value of x. So let us check at x equal to 3. At x equal to 3, f of 3 can be x square, that is 3 square equal to 9, or 3x, that is 3 into 3, which is also equal to 9. So at x equal to 3 also, f gives me a unique value, that is 9. So yes, f of x is a function. So f of x is a function, right? One thing is clear. Now let us move to g of x. Similarly, in g of x, if you see, it is being defined between 0 to 10. Before 2 and after 2, it has got different definitions. Before 2 it is x square, after 2 it is 3x, and at 2 it is x square as well as 3x. So it has got two definition at x equal to 2. So before 2 it is very well defined, x square is a function. After 2, 3x is also a function. But for this function g to be a function, it should give a unique value for every x. So we just need to check for x equal to 2. So g of 2 is equal to 2 squared, right? Or as per this definition 3x, it is 3 into 2. So it is giving 4 or 6. So it is giving two values, right? In this relation, if I write 2 comma 4 and 2 comma 6, two ordered pairs are there in this relation apart from other ordered pairs. So these ordered pairs have got same first element. So I can say that this relation G is not a function, because it has got two values of g of x at x equal to 2. So it doesn't qualify to be a function. And this is how we will check every function, every relation, whether it's a function or not. Now f of x is equal to x square. We need to find value of this. We know that f of 1.1 will be 1.1 squared, which is equal to 1.21, and f of 1 is equal to 1 squared, that is 1. So I just need to place it here. 1.21 minus 1 divided by 1.1 minus 1. So it is 0.21 and 0.1. So you can write it as 2.1, right? You can write it as 21 by 100, and this can be written as 1 by 10. So it will go there. So 10 can be cancelled and it is 2.1. So you should not make mistakes in these simple calculations, okay? I was doing it very quickly, so I got confused for a moment. You should not get confused, because you can take all the time that you have and find it correctly, because this is a simple question and you don't have to do it wrong. Now to find the domain of this function, I just need to find the values of x that make this denominator 0, and then I'll exclude those values from real values, right? So at which value this function is 0, I know that this function, let me factorize the denominator, it will be equal to 0 if x minus 6 minus 2 x minus 6 equal to 0, x minus 2 into x minus 6 equal to 0. So this will be 0 at x equal to 2 or x equal to 6. So I'll exclude these values from the answer. So this is my domain, this is the domain of this function. This R stands for set of real numbers, okay? What is the next question that I have is this one. Domain and range of the real function. We have already discussed plenty of questions like this. Domain, we know all the values of x for which this function is defined. We know for this to be defined, what I put inside it, right, should be non-negative, So x minus 1 is there inside this radical sign, so it should be greater than or equal to 0. It should be, right? If somebody says that it is positive, that is not complete answer. It should be non-negative, right? So x minus 1 should be greater than or equal to 0. That means x should be greater than or equal to 1. This is the domain. And what is the range? So let me write it clearly. What is the domain of this function? It is, I can have 1 up to infinity, right? Because I want x minus 1 to be non-negative, so x can be greater than or equal to 1, which is the domain, 1 to infinity. Now what about range of this function? Anything inside this radical sign will give me a result which is non-negative. It will not give me a negative result. Now we are talking about real numbers here, right? What I put inside this should be greater than or equal to 0, and what it will give me the answer to radical sign. For example, if I say root 4, it is 2, and it is not minus 2, right? This is principal square root of 4, which is 2. It has got exactly one value, that is 2. So anything under this radical sign, this will give me a value which is greater than or equal to 0. So the minimum it can have is 0. So if you look at the domain, I can put 1 as the minimum value of x. Otherwise, every value that I put will be greater than 1. So if I put x equal to 1 here, I'll get 0. So this is the minimum value that I'll be getting. Apart from that, if I put values greater than 1, if you put 2, you'll get 1. If you put 3, you'll get 2, right? And square root of those will give you positive values. So I can get 0 or greater values. So the range is this: non-negative real numbers. So your answer, you cannot write positive real numbers. You have to write non-negative real numbers for the range of this function, because 0 is also included in the range. Find the domain and range of this real function modulus x minus 1. So we know that domain is set of all real numbers, because all real numbers are acceptable here. This function will be defined for all real numbers, and we know mod of something will be always greater than or equal to 0, right? At x equal to 1, it is 0, and apart from 1, at every other value of x, it will be something positive. So range of this function, of course, is 0 to infinity, or in other words, a set of non-negative real numbers, right? See, I can put anything negative also. If I put x equal to minus 2, what will happen? Minus 1 minus 2 will give me minus 3 inside, and it will give me 3. So the range will be positive or 0. When I put x equal to 1, it will give me 0, right? So it is set of non-negative real numbers, and this domain can also be written as minus infinity to infinity. I hope this is clear. I don't have to explain more than this. Look at this. Determine the range. Now what is the function? When I put, this is my first entry and this is my second entry, that means f of x is equal to x square by 1 plus x square. This is the function. And if I look closely, now I need to find the range. So I can write it like this, and this can be further written as this. So this is 1 minus 1 upon x square plus 1. And if you notice, this x square plus 1 is always greater than or equal, it will always be greater than 0, right? The minimum value that it has is 1. So I can say when x is equal to 0, it will have minimum value, that is 1. Apart from that, it will have all the values that are more than 1. So range of this only is 1 to infinity, right? So 1 upon this, let us say I put 1 upon 2, so it will be something lesser than 1. When I put x equal to, let us say, 100, so it will be 1 upon 101, so it will be further lesser than 1, right? But it will never become 0. So 1 upon x square plus 1 will be some value which is between 0 and 1, right? Which is something between 0 and 1, but it cannot be 0, right? So see, 1 minus, this is some value which is between 0 and 1, right? Maximum that this value can be is 1 at x equal to 0, right? So this entire expression will give me my minimum value, as when this is 1 for x square is equal to 0, this entire expression here in this circle will become 1. So 1 minus 1 will give me 0. Apart from that, this is between 0 and 1, right? So it will be less than 1 always, this entire expression, because I am subtracting 1 minus, let us say, 0.3, so it will be 0.7. Okay, You understand? This will never become 0. So this expression 1 minus this will be between 0 and 1. So x will be always less than 1, greater than or equal to 0, right? Where this is my range, right? Or you can say the range of this function will be 0 to 1, where 1 is not included. So this is 1 minus something here, right? And this something can be maximum 1. So when it is maximum, this will be minimum, which is 0, right? If it is not 1, then it is something between 0 and 1, right? When it is something between 0 and 1 and it is being subtracted from 0, if it is 0.3 it will be 0.7, if it is 0.7 it will be 0.3, right? So the range is this, between 0 and 1, where 0 is included, 1 is not included. Fx given, gx is given, f plus g, and these are defined on real functions. So f plus g is x plus 1 plus 2x plus 3, that is 3x minus 2. F minus g of x. So I have to subtract these. X plus 1 minus this. So x minus 2x is minus x. 1 minus minus 3 will be plus 4. So this is f of minus g. F by g is equal to x plus 1 divided by 2x minus 3. Now I have to mention that x is not equal to what? 3 by 2. Why? Because 2x minus 3 becomes 0 at x equal to 3 by 2. So I will exclude this value, right? So x can be any real value except 3 by 2. Let us do some more questions really fast, because these are very simple questions. Now this is defined from z to z. This function is ax plus b, which is linear function for some integers a and b. We need to find ab. Now these relations, these ordered pairs will satisfy this, because these are the coordinates through which this line passes. So f of 1 is 1. F of 1 is 1. So let me put it. F of 1 is 1, which is nothing but a into 1 plus b as per the given rule. So this gives me my first equation, a plus b is equal to 1. And what is f of, let us say I use this coordinate. F of 0 is minus 1. F of 0 is minus 1. And what is f of 0? I put x equal to 0, so it will give me b. So this directly gives me value of b as minus 1. And if I put b equal to minus 1 here, a is 2. So what is my function? F of x, a is 2, so 2x, and b is minus 1, so 2x minus 1 is the desired function. Okay, let us look at this one. R is a relation n to n, where R is this and this is the formula. This is the relation with which it is defined. Are the following true? Now this belongs to relation for all a belonging to natural number. Is this true? The first part, a comma a, is this included in the relation? Let us check. When I put a here, see, I am getting these ordered pairs, where this is something that I am putting and this is something which I am getting. So b square is equal to a. So b is equal to what? Plus minus root of a. Just I need to check. So to avoid the confusion, let me write this for a moment. Let me write this as x comma y, where x comma y belong to natural number and y is equal to, or x is equal to y square. This is the relation that is being given. Now because here also it is given a comma a, that is why to avoid the confusion I have written this. So y has to be equal to plus minus root x. So if I put x equal to a here, am I getting answer as plus minus root of a? No. So this doesn't belong to the relation, or it is not true. What about this second? If a comma b belongs to R, then B comma A also belongs to R. Let me check. If I put A, what is the rule that is given? This is my rule. You need to focus on this. If it is saying A comma B belongs to R, that means B is equal to plus minus root A. Then B comma A also belongs to R. That means A is equal to plus minus root B. So does it imply this? No. So this is also not true. This second part is also not true. What I mean is, if y squared is equal to x, that means for this ordered pair, if b square is equal to a, does it imply a square equal to b? No, there is no such implication, right? If square of 2 is 4, then square of 4 is 2. No, this doesn't imply like this. So second part is also not true. What about this third part? If A, B belong to this relation, B, C belong to this relation, that means B is equal to plus minus root A, C is equal to plus minus root B, then C is equal to plus minus root A. So if you see, given these two facts, does it imply this fact? No. So this third part is also not true. What you can do, you can place some numbers here and then check. Right? Let us move to the next question. Are the following true? F is a relation from A to B. For F to be a relation from A to B, it has all the ordered pairs here should be a subset of A cross B. So the first element should be from A, second element should be from B. So let me check. First elements are 1, 2, 3, 4, 2. 1, 2, 3, 4. So yes, first elements are there from A. What about second elements? 5, 9, 1, 5, 11. 5, 9, 1. See, this second element here is not from this B, right? No, yes, it is there. It is there in B. So second element 5 is also there. 5, 9, 1, 11. 5, 9, 1, 11. So yes, all the second elements that are there are from B. So I can say that yes, this is a relation from A to B. Okay, you noticed how I checked it? That is what you have to do. Now f is a function from A to B. I just need to check the first elements. Is it being repeated somewhere? 1, 2, 3, 4, 2. It is being repeated. First element, that is 2, is being repeated. Or for x equal to 2, I am getting two different values, that is 9 and 11. So it is not a function. Okay, I think I have justified my answers as well. Now look at this one. F is a subset of Z cross Z defined by this. A, B belongs to Z. What is the function that is being given? It is equal to A plus B, right? Is F a function from Z to Z? What I am trying to say here is f of AB is equal to A plus B. Now for it to qualify as a function, it should not give me two values at a value of x. So let me check. This is what my input is, this is what I am getting outside. So I'll make two cases. Let us say A is equal to 1 and B is equal to 8. So what is AB? AB is equal to 8. So f of 8 is equal to 1 plus 8, that is 9. Right? And how else can I make it 8 here? Let me take A equal to 2 and B equal to 4. So f of 8, 2 into 4, that is f of 8 in this case is 2 plus 4, that is 6. So I am getting two values at x equal to 8. So it doesn't qualify to be a function. This here is not a function. Alright. Look at this one. Set A is this, and this function is defined from A to natural numbers. F of n, the highest prime factor of n. Find the range of f. So f of n is given as highest prime factor of n, right? F of n is highest prime factor. So what is input values? What are the input values? I am going to put input values from this set, which is 9, 10, 11, 12, 13. So what I am looking for is highest prime factors of these numbers that are written here. So if I write f of 9, what is the highest prime factor of 9? That is 3. This is what I am looking for. F of 10 in this case, what is the highest prime factor of 10? 5. What is the highest prime factor of 11? 11 itself. What is the highest prime factor of 12? 3. And what about 13? Highest prime factor is 13 itself. What is the set, or what is the range of this function f? It will be 3, 5, 11, 13. This is the range that I am looking for, right? I hope I have written everything. 3, 5, 11, 13. Okay. So do we have any more question? No, I think this miscellaneous exercise is complete. I hope you have understood this chapter very well, relations and functions, and if you understand this chapter here in class 11th, it will take off a lot of burden in class 12th, right? Even if you are in class 12th, you have to come to this playlist, first listen to this and then go to class 12th. So it is important that you understand it here while you are in class 11. Thank you.